Alright, here we are with EI Lesson 7. We're comparing numbers in scientific notation. This gets pretty fun because we're comparing really large numbers of some measurements and things like that. This is pretty fun. So we know that the approximate diameters of the planets in our solar system are listed in the table below in either standard or scientific notation. We'd like to complete the table, so we're just converting between scientific and standard notation again, just like the last lesson. I strongly suggest that you pause this video and try to do this yourself before watching the video. If you have not already done this assignment, please turn this video off, do it yourself, and come back if you would like to see the answers. So, okay. Hopefully you've had time to pause it and try it yourself. If not, do so now. Diameter in scientific notation. We have moved the decimal to the left by 3 to get 10 to the third, so we're going to move it back to the right 3 for 1, 2, 3. 4,800 what? This is kilometers. That's a large amount of space. It's pretty big. Okay, so this one we got 1.21. And to get there, we move the decimal 1, 2, 3, 4 times. For this one, we move the decimal 4 times, so we have 1, 2, 3, 4. And that is the approximate diameter of the Earth. That's good. Diameter of Mars, this is 6.792. We move the decimal 3 times to the left, or to the right, rather. Likewise for Jupiter, we're moving the decimal 5 times. Here is 1, 2, 3, 4, 5. Jupiter is a lot bigger than all of the other planets. Here we have Saturn, also quite a bit bigger than Earth and some other smaller planets. This is 1.205. We move the decimal how many times? 1, 2, 3, 4, 5 times to do that. So 10 to the 5th. Uranus, move the decimal 1, 2, 3, 4 times to get to 5.11. Here we have 4.953. I'm going to move the decimal 4 times. The point was here. Now we're going to go 1, 2, 3, and 4. The fourth one will add a 0 for that. And make sure we use our units. These are all kilometers, and we could just say all units are km. So we can be lazy and not write it out as much. And then right here we have 2.3 times 10 to the third. Move the decimal, move the decimal once, twice, and 3 times. Pluto is definitely the smallest planet, if you can even consider it a planet, which meteorologists and astrologists do agree. Sorry, astrologists, not meteorologists, are now saying that Pluto is not actually a planet, sadly. Which 3 planets have the greatest diameter? That's definitely Jupiter, Saturn, and Uranus. Justify your reasoning based on scientific notation. We have 10 to the 5th for Jupiter, 10 to the 5th for Saturn. So this is the really high order of size here. And it looks like I actually may have screwed up. Yes. No, I did not screw up. I was looking at 142,900 kilometers and thinking that was in the millions. It's not actually. It's 142,000. That's why I thought that I had made a mistake, which would mean that these orders should have been different, but they're not. So we're good. Everything's good here. It turns out this is the largest because it has a 5th power, and this is the second largest. It's the only other one that has a 5th power. Now we must pick from the 4th powers to see which is the next largest, and this is 1 to the 4th, 1 to the 4th, 1 to the 4th. Well, we already chose that one. And then 5 to the 4th and 4 to the 4th. So the next largest planet is Uranus, followed by then Neptune, and we could continue after that. Which planet has the least diameter? Well, that's Pluto. It has the lowest magnitude in the scientific notation, 10 to the 3rd. The moon has a diameter of 3.5 times 10 to the 3rd. Which planets have a smaller diameter than the moon? Well, that's just Pluto. There's anything else out here with a diameter smaller than that, which means Pluto's not really a planet. All right. Now we're looking at the speed of 2 mediums in the air, the speed of sound in meters per second. We're going to complete the table by writing the speed of each medium in scientific notation or in standard notation. So we need to fill out this box and this box as well. Once again, if you're watching this video, I hope that you've attempted these problems on your own before watching the video. So let's do the speed of sound. In scientific notation, this is 3.3 times 10 to the 1, because we moved the decimal over by, oh, excuse me, 2, because we moved the decimal over twice. And this one, this is the speed of light, significantly faster. We're going to move the decimal 8 times. 1, 2, 3, 4, 5, 6, 7, 8. Put some commas in so we can kind of see it's 300,000 meters per second. That's very, very, very fast. And what is most likely to occur first? A person seeing a flash of lightning or a person hearing the sound of thunder? How do we know based on scientific notation? Well, definitely we're going to see it first because the speed of light has an order of magnitude of 8, whereas the speed of sound has an order of magnitude of 2. A technician reads and records the air pressure from several pressure gauges. The table shows each pressure reading in pascals. That's abbreviated PA. Pascal is the unit used to measure the amount of force applied on a given area by air or other gases. So it's a measurement of pressure. Justify your reasoning for each question. Number 1. Which pressure gauge has the highest reading? There are several ways to kind of look at this. I think since we already have 2 in standard form, we'll convert this to standard form as well. This is 5, and then we're going to move the decimal 5 times. 1, 2, 3, 4, 5. 520,000 pascals. That's a lot of air pressure. Definitely pressure B. Which one has the lowest reading? Well, now we know it's C because we have them converted to the same form. The atmospheric pressure was 1.1 times 10 to the 5. Let's convert that to standard form since we have the rest of them in standard form. We're going to move the decimal 5 times. So 1, 2, 3, 4, 5. Notice when I do that, I am moving the decimal the first time on the 1. And so I'm not just adding 5 zeros. Okay. Let's say this is 110,000. Were there any gauges that showed a pressure reading greater than the atmospheric pressure? Yes, all of them. Which makes sense. It's really uncommon to have negative pressure unless you're doing some barometric experiments of some kind or in special chambers or vacuum chambers and so on. So there we go. They all had a reading greater than the atmospheric pressure. See you in lesson 8.